my name is Maksi Thompson and I'm a 3D technical artist. At Sailing Studios, we've been dedicating ourselves to creating high-end CGI content for marketing purposes. So what we do is we utilize 3D rendering technologies, which was mainly applied for the game industry up to these recent years, and we're starting to apply that to create photos and videos which are photorealistic. My background before moving to 3D was a photographer actually. So I was just a standard photographer working for mainly photo shoots of people. So I was more of a portrait photographer, specializing also in lighting for portraits. That's what kind of then broke off and took me to the path at which I'm at now. Well, so I think as well as obviously, there's obviously positive and negative things about 3D. So the advantages mainly is being a photographer, I was requiring a lot of equipment, a lot of space, a lot of time, and a lot of things were quite difficult to actually photograph with traditional means and traditional lenses due to maybe their small size or their massive size. These were the main problems actually that took me onto the path of 3D. Thanks to 3D now we do have virtual environments in which we can say the physical laws don't apply, so we can get as close as we want to an object or as far away as we want from it. We can have as many objects as we want, we can have any color object we want, so it gives us much more flexibility on the types of projects we can work on and the amount of time. Obviously, a very quick example would be if I wanted to have a photo shoot or a video of a product falling inside of a water container, then I'd have to find a studio, fill it up with water, takes up space, set up all the lights. Just for that one shot, we can do it digitally, avoiding all the time and costs. And if there's any mistakes, we can just go back on our work and iterate without having to recreate an actual photo shoot. The main challenges though of 3D is that I do feel that you do lose a bit of that realism, that it's never going to be a photography. There's something about the traditional means which we also really like, which is why we're trying to focus so much on trying to make it as realistic and as photography-like as possible. But there's just some things which with photography does look better. Sometimes it's the imperfection that actually sells the image more, makes it better and makes it unique, which is something that with 3D you don't get. Everything is exactly perfect because it's a perfect world environment. So that's kind of a challenge. And then there's a lot of different softwares which people have to learn how to use in order to actually be able to create. So you're compensating on equipment costs, but you are adding a lot more programs to learn. So obviously the main challenge for softwares now is pretty much what the computer can handle. So it's very much a machinery block rather than software blocks. Basically the computational power to run simulations, for instance water simulations, dust simulation, fire, explosion, pyrotechnics, everything you might actually see in a traditional Hollywood movie as well, requires a great amount of computing power in order to actually calculate all of that simulation, because it's physically based. So it calculates particle by particle how it would actually interact with its environment, and it just takes a lot of time and a lot of memory. So sometimes for something which is 10 seconds long, it could take you 24 to 48 hours just of calculation, and if something goes wrong, well then you're having to redo those 48 hours of calculation once you do the little adjustment. So it takes a huge amount of time, and when you grow in scale, we're still obviously a small company, but Hollywood companies or companies who work with big CGI can take weeks or months to just calculate something for rendering. That's probably the biggest limitation with it right now, because in terms of quality and in terms of realism, I think we've really hit the spot. But it's computational power that is always a big problem. RAM space as well, just in storage, it can be 20 terabytes for just 10 seconds of video, and obviously sometimes it becomes a bit over the top, let's say, in how much you have to use. And obviously the idea is that the faster you can do it, the more projects you can probably take, and ultimately, it's a balance between how many projects you can do with the fast machines you get. So that's why obviously faster machines means more projects. For now we still don't know where it's going to head, so one day you could easily just create whatever you wanted just by like that. as of right now, we're not yet there. So for instance, an AI needs to be trained on something specific. It needs to have a visual images of references in order for it to recreate it. A client cannot come to us with their product if it's not a massively famous product, and the AI will most likely not know what it is. So as of right now, the AI is not there yet to take over us. In the future, though, it is something that could potentially be quite a potential risk. I always feel that the best way to stay on top is to utilize the AI together with our work. So rather than becoming overtaken by the AI, we start to adopt AI in our workflow, so we always stay ahead of the curve. A few ways we do that is we can use AI to fasten up the workflow by generating in between frames. So rather than rendering out 24 frames, we render out 12 frames and create in between frames through AI. There's a lot of things which can help us speed up that workflow utilizing AI, which wasn't possible before, so it's also an added help in that sense. A general workflow, basically, the way it works is that we always start with references. So we have reference about something we need to either create from scratch, from design references. So sometimes it's a product which has never been built before and it's a design. Sometimes it's something which has already been produced and we have pictures of it. The first step is to recreate this in 3D, so to model it. There's different ways we can model it. We can either physically recreate it in a program, so through the computer. We can also photo scan objects, which means we can actually use cameras and by taking pictures of the same object through lots of different positions, there are softwares that can actually recreate these objects in a three-dimensional space. And then once we've got the actual object, then we have to texture it. So it means that we actually have to apply materials to the objects. And that's obviously quite a long process, in the sense that you have to physically add the leather material, the straps. If you have any sewings in it, you have to physically have it in there, and then it goes off to the lighting stages. So once we're happy with how the model looks, we bring it in the scene, we light it up, animate it if there's any animation necessary, and then once we're happy with the result, we export it and go into the rendering stage, which is where it literally creates frame by frame of the whole animation, and then we put them together. So the lighting, rendering and animation is pretty much like the compositing photographic side of the traditional photography side. So it's all about the framing, it's about how you light the object, it's about how you tell the story through movement, how you tell the story through the animation. And that's all sorts of skills as well, which you can also sometimes, in depending on the size of the project, we might require to also have specialized animators come in to do some very specialized work. So there's a lot of different skills, and then there's also, which is why my job is a technical artist. The technical artist basically oversees all of these smaller steps and takes all of these small steps all the way to the rendering side and ensures that it gets rendered out and into something that now can be passed on to post-production and edited, color graded, and if any compositing has to be done in post, then that's where it's going to be done. So the main programs that we actually use currently are Blender, Unreal Engine. Those are rendering engines, so we use them mostly for rendering, although Blender can do a lot of the modeling as well. We also use Maya mainly for the 3D modeling, which is an industry standard modeling tool. Then we have Houdini, which is mainly used on our side for the more particles, VFX, simulations type of software. And lastly, we have Substance Painter or Mari, which are texturing programs, which is where I was saying about creating realistic textures. The way they all work into play is obviously the first part would be using Maya or Blender to do the modeling. So we'd be doing the actual 3D model. A while ago, obviously, 3D modeling didn't exist, so this part would actually be where the client would have to physically come into store with all of his models, maybe depending on what the photo shoot was, but he'd have to bring the prop physically to the studio, and then that would be this part basically eliminated. So now we do the 3D modeling, so we have a digital asset forever in our database without needing to move any people around. The second part then goes up to Mari or Substance Painter, which is where we do the texturing. Of course, also this part you probably wouldn't have a long time ago. They would just come in with with the finished model and given to you the finished product. In this case, we obviously have to texture it and do all different variation. The advantages of this is that this is digitally done, so if you have maybe one item which has 100 different variations of color or texture, well, for us it's as simple as a click of a button, and it changes the textures, rather than having to physically bring there 100 different items to the studios and having to swap them over after every shoot. Then after this, we'd go on to, once we've obviously set up everything, go to the shooting side. This is done through Unreal Engine mainly, sometimes Blender, depending on what's needed. This is where we actually go in and set up the scene. This is a traditional photography aspect, but it's done digitally. So imagine your traditional photo studio, you walk in, there's a product in the middle, and then you start setting up the camera and the lights. The advantage of it is that you know how much space lights can take up, and how much time consuming it can be to actually physically move around all the lights, and it's expensive. Lights are very expensive to have a full studio. The advantage of doing it in 3D is exactly that, is the fact that if we want to add 100 lights in one scene, we can add 100 lights. If we want to remove 100 lights, it's as quickly as deleting them, rather than physically going there and switching them off or having to move them around. Also for all the health and safety, obviously people moving around, you can't just leave lights lying around in the studio. We're eliminating all these problems, and it's a one-man band job. So each 3D artist we have can be working on a single project at a time, whereas in a set you'd need multiple people, because there's so many moving parts that if for safety you'd need someone looking after the lights, someone looking after the props, someone looking after this, making sure that the things are moving forwards and efficiently. And then there's a rendering. This is just comparable to just your, well, if we look back at the ones, this would be where you would actually go into your dark room and export all of the negatives. This is where the exportation gets done. We're actually materializing into an image what has been previously captured in the software, and creating something which is visible from it. And that's the whole workflow condensed into its different stages. Ultimately, it's a very difficult question, because obviously there's a lot of uncertainties due to AI as well on how this can progress. Where I would like to take this in very few words is being able to take the Hollywood CGI quality of what you're used to in the high-end Hollywood movies, and be able to take that to the advertisement industry, but for a much more affordable price. Obviously, as of right now, these kind of technologies are reserved for the elites, high-end Chanel, Gucci, the big companies usually have the amount of budget required to do these kind of visual effects. But as technology is becoming more accessible, softwares are becoming cheaper, also machinery is becoming relatively cheaper year on year, but also more and more powerful, which gives us now the chance to actually step into the industry and kind of be able to create these really high-end quality visuals without having to obviously have the massive 20-30 people studios working on single projects. So that's where I would like to be able to take that Hollywood realistic quality, and the ones that blows your mind away when you see on screen and you go, how did they do that? And take it and take it to the advertising industry for the people who don't have 100 million euros of budgets. So having said all this, the best way to show you a bit of everything is to give you a little example, and I'll take you in our virtual tour of our little apartment. So there are a few advantages of creating a house in 3D. Once again, the way we define them are called digital twins. So we actually work with digital twin of houses for a number of different reasons. The first one is, since we're a marketing company, it helps us create and produce marketing content such as videos or photos of a house, and sometimes potentially even before the house is actually built. So based on the floor plans of the house, we talk with architects and we talk with interior designers, and we can actually come up with a photorealistic and accurate representation of the house through images and videos. This is the most simple one. This is the one we've been working on, and it was basically promoting the house through agencies online, through social media such as TikTok and Instagram, and basically it was targeting a bit of a younger demographic, and that's why it was advertising through these platforms. So with them, we recreated the whole house, and we basically started capturing different
angles of the different housing, and the advantages was that we could actually test different furnitures inside, we could test different styles. So we also gave the ability for the people then further on to buy it to have a better idea also of the different kind of interior designs, interior styles they could have. Another application that we've actually used for interior houses actually was that sometimes when you have a house which hasn't been built yet, but they show you the floor plans, it's a bit difficult to understand the proportions of the actual house, so how big the dimensions actually are. Seeing a drawing of a room doesn't really give you the sense of scale of how big that room is, how many people fit in there, what does the kitchen look like, how much does the table fill. So 3D and virtual reality actually gives us the ability to immerse the user into a one-to-one space, which obviously is a virtual world, but with their own house. So they can see the house before it's been built, they can see how big the rooms are, they can make decisions on the moment, and actually fully understand what these decisions are, based on seeing the actual digital twin of the house. This is helpful once again for not only understanding the building of the house, the dimensions and all of that, but also when it comes to having some sort of interior design done to it. So furnitures, a kitchen, all of this, it allows you to actually see what would the kitchen look like inside of the house, how big will the kitchen look, how much space does my bed take, or different combinations of furnitures inside of the house before you actually buy the furniture. So it's a very versatile technology, and it allows us to really give the customer the ability to immerse himself into a new space, understand, see things. And the advantage on top of that is that a lot of the times the houses aren't even built, but the user still gets to experience the final product and get a full-on idea on how it will be.